Hey, what's up, Logic fans? Welcome to video 3.1b, our second video on section 3.1, and we're going over the MIT technical details of the rule Simp, okay? What it allows you to do and what it does not allow you to do. So here's another example here. Let's jump straight into it. Okay, so I've got a string of symbols here. Remember, it's meaningless. It's just a random string of symbols. This is syntax. From this string of symbols, can you infer or write down this string of symbols via the rule Simp? Does the rule Simp allow this, or does it not allow it? Prohibited or allowed? Okay. Pause and give that a second. I'll give you a second to pause before giving the answer. If it is allowed, what's the value of P? And what's the value of Q for that matter in this case? Okay, so this is allowed. This is A-okay. You can do it. Feel free to do it to your heart's content. The value of P is just A. The value of Q, of course, is just B or C in this particular case. All right, let's try another one. I just want to emphasize, we did cover this point in the last video, but just to make it absolutely clear, does Simp allow this inference? If so, what's the value of P? The answer, okay, pause it. The answer is no. This is not allowed. This is prohibited. This rule Simp says you can infer the left part. I didn't say you could do the right part, right? You've got to interpret my rules very strictly. And this is what they allow and what they don't allow. So this is not allowed, okay? Do not do this. Simp does not allow that in this system, okay? If you're coming at this from a different logic course, or a different textbook, be sure to check with your professor or that logic book about what those rules allow and what they don't. People develop their systems differently. This is how we're doing it in ours, okay? What about this? Does Simp allow you to do this? If I have this in here like that, okay, and then I infer B using Simp, is that allowed? No, not allowed. Don't do it, okay? You've got to obey the main connective, okay? This is the main connective. What's on the left of the main connective? A. I don't see a B on the left of the main connective. Not allowed. You're not allowed to do it. Why not? Because I make the rules, and that's what the rule says, okay? It's meaningless symbol manipulation. That's the whole point of syntax. It's a different way to analyze validity, okay? We can look at it from this purely syntactic point of view. Okay. All right, let's try another rule here. I think that's pretty good for the ins and outs of Simp. Here's another rule of inference, and I will talk about the difference between rules of inference and what we're going to call rules of replacement later. But let's not overwhelm you. Let's just stick with this new rule. Here's your new rule. I'm your God, and I'm giving you this new rule. If you have two strings, one that looks like this, okay, and another that looks like this, okay, then you may infer this one. So in other words, you can sort of detach this one and put it down, making no other changes to it. So if you think about it semantically, the idea is that, okay, if I've got P or Q and I've got the negation of the left disjunct, I can write down the right disjunct. Okay, and we're going to describe that as DS, which is Disjunctive Syllogism on lines 1 and 2. So in this, with this particular rule, you have to have two lines. It's on two lines, okay? And you're inferring something from the two combined together, okay? So let's do some examples to make sure you understand what Disjunctive Syllogism allows and what it does not allow, what's permissible and what's impermissible, okay, what's prohibited. Okay, so this is this a legitimate application of the rule DS? Okay, are you allowed to make this maneuver? Are you allowed to do this? Is this a permissible or an impermissible maneuver here? So you've got two lines, which is great. You're supposed to have two lines. One of them is A or B. The other one is not A. And from this, the person wrote down the string of symbols B. And they said that they did that by disjunctive syllogism on lines 1 and 2, where P was A and Q was B. Permissible or impermissible? All right, this is permissible. This is absolutely okay. You're allowed to do this, okay? So feel free to do it. Some students ask, Ash, what if it had been not A on top and A or B on the bottom? Like if it was 1, not A, to A or B, would that still be permissible if you were inferring B? And the answer is yes. Okay, that order won't matter as much. Okay, I am a jovial God in that way. I will allow such things. Okay, and I don't particularly care what order you write these in either. Okay, if it's 1, 2, or 2, 1. All right. Okay, so let's try another one here. How about this one? Is that permissible or is that impermissible? Go ahead and try. Take a second to think about that. Does the rule disjunctive syllogism allow that? And the answer is no. Okay, you cannot do this. Disjunctive syllogism does not allow us. Now, there's a sense in which it's a valid argument. Like if you're thinking about it semantically, right? If either A is false or B is true, and A is true, then it's got to be the case that B is true. And so if you run it through a truth table, you will see that this is a valid argument where these are the premises and this is the conclusion. And that's fine. There is going to be a way to get from these two to this desired conclusion syntactically as well. The question in front of us right now is whether DS allows it, and the answer is no. DS does not allow this, okay? What DS says is that you've got to have a disjunction, which you have here, and then you've got to have the negation of the left disjunct. This is not the negation of the left disjunct. Now, it's logically equivalent to one, but that doesn't matter. We're not allowed to use concepts of logical equivalence. Why? Because that's a semantic notion. And what we're talking about here is syntax, right? It all matters what's the string of symbols look like, okay? And this string of symbols is not the negation of this string of symbols, okay? So this is not allowed. This is prohibited. This was impermissible. Don't do it. Let's try another. In fact, to drive the point home, let's try this one. Is that permissible or impermissible? Is that a legitimate or an illegitimate use of disjunctive syllogism? Okay, that's legitimate. That's okay, because this here is in fact the negation of this string. Okay, and so it fits this form, this model perfectly. Okay, and that's perfectly fine. And by the way, if we had had this here, that would be legitimate as well. And if we had had something like this, let's just try to make it, more complex for you. Then you had this, okay, this would be a permissible use of disjunctive syllogism as well, okay. Now it is one side specific, so let's go down in complexity here. Let's do this. Let's say that you had not B and you had A. Okay, is that permissible? Or is that impermissible? Is that a legitimate use of disjunctive syllogism or an illegitimate use of disjunctive syllogism? Okay, that's illegitimate. It's one side only, okay? So you have to have the negation of the left side, and you're allowed to infer the right side, okay? There is going to be a way to get this syntactically, but in one step with disjunctive syllogism, no, that is not allowed. Okay, one more to round out the study of disjunctive syllogism here, and there's plenty of problems in the book, okay? Is this a legitimate application of disjunctive syllogism or an illegitimate? Permissible or impermissible? Pause now. Okay, this is permissible. This is allowed. This is okay. Go ahead and do it, all right? So it doesn't matter how complex the P part is. So in this case, P is just A if and only if B, and Q is just C. Those are the values, okay? So keep that in mind, and sometimes we don't specify the values because it gets easier to see as you go, but technically we should always put them in there if we're being MIT meticulous, okay? Okay, let's try an example where you might have to combine some rules. So the only two rules we have right now are simp and disjunctive syllogism. So here you're supposed to show that this is syntactically valid. That is to say that you can get from these two givens, you can get from this string and this string to this string, okay? I'm going to give you a hint in a sec, but pause now and see if you can carry out that task. Okay, so here's your hint. Okay, I'm going to get you started. You get started with something like this. Here's your premise, your two premises lined up across the top. Okay, you've got this string of symbols available, and you've got this string of symbols available. And you're going to have to use Simp and DS to try to get to not B. Okay, so our goal here is, I'll put the goal over here. Your goal is not B. Okay, that's supposed to be what you're supposed to get to from these two. Now, see if you can pause from here and finish it. You've got Simp and Disjunctive Syllogism available. Okay, so here's the full solution for you, all right? And this is a syntactic deduction of this conclusion of this string of symbols from these two strings of symbols, okay? And we've got from these two givens to this by following our rules, okay? That's the whole point here. So what we're going to do now is just sort of show you how we did it. So 1 and 2 can combine because we've got the negation of the left side of an or, right, as our second premise. And so when we apply disjunctive syllogism to lines 1 and 2, we get this part here. And the value there that's the value of Q here. Okay, so Q is equal to not the case that B and C. Once we've got not the case that B and C, we inspect that and we realize, oh, I can apply the rule Simp to that to get not B. Okay, and those are the kinds of skills and combinations that we're going to be developing. So you're looking at the lines that you have and you're looking at your rules and you're trying to figure out how you can combine them to get to the thing that you want. Okay. I'll talk more about those kinds of strategies later, but for now I just want to introduce you to some of these rules. So here's a new rule, and this is probably one of the more straightforward ones, but if you have two lines, so once again you have to have two lines. First line's got whatever in it, call it P. Second line's got whatever in it, call it Q. You're allowed to use the rule conjunction, which we abbreviate Conj, to take this string and put it together in one line with this string, with the ampersand in between. So intuitively, if you're thinking about it semantically, from P and Q, you can infer P and Q. But we're not thinking about it semantically. Syntactically, if you got a string of symbols like this on one line, and you got a string of symbols like this on another line, then you can get a string of symbols like this on another line, okay? And you're going to justify it by writing conj on 1 and 2, okay? So let's do an example really quick of that. Okay, so in this case, you're supposed to go from these two strings here, if A, then not T, and C, if and only if not D, to this whole string here. And you may have to use conj to do it, so give that a try. Okay, so in this case, it's pretty straightforward, right? You're just taking this whole thing as P and this whole thing as Q, and you're combining them using the rule conj on 1 and 2. And once again, the value of P is this whole thing, okay? And the value of Q is this whole thing. All right, so I'm trying to show you that, you know, we start building up to more complex things, and you can see more complex applications of the various rules. All right, I don't want to rush our discussion, so I'm going to cut to another video. Look for 3.1c. We'll introduce a couple more rules. I'll give you another example to work through, and we'll call it a day for this lesson.